So in my previous video, I briefly went over periodic trends. And periodic trends, specifically atomic radii, as well as electronegativity. But I really wanted to go more in depth on atomic radius, in particular, specifically in relation to ions. So you may get a question at some point that says, arrange the following in terms of increasing size. Following in increasing size of radii. And for example, you can have nitrogen 3 plus, that's nitrogen 3 minus, nitrogen 3 minus, oxygen 2 minus, fluorine minus, and then we're gonna do just ions, sodium plus, magnesium plus, and aluminum, magnesium 2 plus and aluminum 3 plus. So typically speaking, what you want to think of in terms of atomic radii is I'm going to draw these in terms of the amount of valence electrons, because I think that would be the easiest. And I'm going to show that the electrons that are gained are going to be in pink, and the electrons that were originally there are going to be in purple. So for nitrogen specifically, this is just the valence electrons. We're going to have we're going to have 1, 2, 3, 4, 5 electrons, and then you have 1, 2, 3 electrons gained. For oxygen, we're going to draw that as well. So oxygen, but this time it has 6 electrons. So 1, 2, 3, 4, 5, 6. And the ones that are gained, I'm just going to show in pink, 2. And fluorine is going to be very similar to them. That is definitely not the same size, but it is what it is. And there are going to be 7 electrons on the outside. And then you have this 1 electron that's gained. So that allows it to be negative. For sodium, magnesium, and aluminum, you're going to have a full octet for all of them. So magnesium, sodium, aluminum, and I'm going to use a larger thing so I don't have to use so much effort to make these. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So how can we determine which of these ions is the largest and the smallest? So the first thing you want to think about is how many protons do these have? So 7, this is 8, this is 9, this has 11, this has 12, and this has 13 protons. And the amount of electrons it has, all of these are known as a new term that you may have heard, isoelectric, meaning they basically have the same amount of electrons on the outside. And all of these isoelectric ions have 10 electrons. Now, remember that positive and negative attract, and you have 7 positive charges in nitrogen, but you have 10 electrons, and that's how I'm going to shorthand the electrons. And you have 8 positive, 10 electrons, 9 positive, 10 electrons. 10 electrons. I know this is a bit redundant, but hopefully this will kind of make sense after the redundancy. So when you're looking at these, that looks like a 7, that's just a positive. When you're looking at these, you can see that there's an uneven amount of protons versus electrons. So if you are positively charged, you're going to have more protons. And what these protons are going to do is they're going to pull in these electrons to make this atomic radius, ionic radius, smaller. So the greater the difference in the charge, the more it's going to be pulled in. So aluminum is going to be the smallest radius. Magnesium is going to be the second smallest. Sodium will be the third smallest. And then this here is pulling in, but it's 1 electron extra, so that will be next. There's 2 extra electrons, so that will be following that. And then there is 3 extra electrons on nitrogen. So the size is dependent on the amount of protons comparatively to the amount of electrons and how much control those positive charges in the nucleus have over those external electrons. Now, the larger the atom is, the more difficult this nucleus has control over those electrons. But for smaller electrons such as oxygen and fluorine, they do have a lot. The nucleus is pretty close to those electrons, so it does have the ability to pull and make those things smaller. And hopefully that clears up some misunderstanding about ionic radii. And remember, as I said in the previous video, if you are ever lost on atomic radius, meaning that there's no charges, remember that francium is all the way to the left of the periodic table and all the way down, and that is your largest atom. So the closer you are to francium, the larger you are. And the further away from francium, the smaller you are. I hope that helps clear up any misunderstanding that